If you drop aluminum into hydrochloric acid, there will be a reaction which forms aluminum chloride and hydrogen gas. If 42.9 grams of hydrochloric acid are mixed with 27.5 grams of aluminum, how much of the excess reagent will be left over? This is a limiting reagent question, which is a subset of a stoichiometry question, and you know this because it is asking about the excess reagent. So here are the 5 steps for determining which reagent is limiting. Start by having the correctly balanced equation. For this reaction, this is the balanced equation. Convert grams to moles where necessary. For the hydrochloric acid, you take the 42.9 divide by the molar mass, and you start with 1.18 moles of hydrochloric acid. Do the same for the aluminum, dividing by its molar mass, and you get 1.02 moles of aluminum to start with. Now, for each of these, divide by the coefficient of that chemical. So for the hydrochloric acid, you can divide 1.18 by 6 to get 0.197. For the aluminum, you're going to take the 1.02 moles, divide by 2, and get 0.51. Now compare those two answers. There are 2 possibilities. The answers are the same, or the answers are different. And 0.197 is not the same as 0.51. So the answers are different. When that happens, the chemical with the smaller answer is the limiting reagent, so the hydrochloric acid is the limiting reagent. The other reagents are the excess reagents. Now, you may be asked to proceed further in the stoichiometric problem, and so in that case, the limiting reagent is the if chemical. And here you are asked for the grams of excess reagent being left over, so we have to go do some stoichiometry. So here are the 8 steps for doing a stoichiometry reaction. First, determine that it is a stoichiometry problem, and we've already done that. Second, be sure the equation is balanced. That's already been done. Determine the if chemical, and in a limiting reagent problem, the limiting reagent is always the if chemical, so here the hydrochloric acid will be the if chemical. That makes the then chemical aluminum. So basically you can say if there are 1.18 moles of hydrochloric acid, then how many moles of aluminum will be used up? We don't need to calculate the moles of the if chemical. We've already done that. So now we're going to set up the then-if ratios. So we have then over if equals 2 aluminum over 6 hydrochloric acids equals x over 1.18 hydrochloric acids. Now we're going to solve for the unknown. So we're going to cross multiply the 2 and the 1.18, divide by the 6. When you do that, x equals 0.393. So 0.393 moles of aluminum were used up. Do any other calculations needed? The question asks for grams of the aluminum that are left over. Well, the moles of aluminum left over equals the starting moles minus the moles used up. Plug in the values, you get 0.627 moles of aluminum left over. Once again, we want grams. So you take the number of moles, multiply it by the molar mass of aluminum, you get 16.9 grams. So now we can give the answer. There will be 16.9 grams of aluminum left at the end of the reaction.